Well, hello guys. It is April 7th, so this is our first video back from our spring break. Kind of a different spring break than we normally have. But we are going into chapter 10, which is on area and surface area as well. And so we're going to try to tackle areas of parallelograms and triangles in this worksheet. And there's a couple things that I want to tell you before we actually get started on this, because they're going to come up a couple times during this assignment. They're going to ask you about perimeter, and the perimeter of a shape is the sum. So since we say sum, it means we're adding up the sum of all exterior sides of a polygon. So that's what we're going to be. I didn't get all that in there, but the sum of all the exterior of the sides of the polygon. So we got to add all those sides up. Sometimes they're given to you, sometimes they're not, and so you have to use some good thinking skills to be able to grab all of the exterior sides and add those all together. So remember, this is a whole separate question in and of itself. And the other one is going to be the area of each of these polygons. And the ones we're going to be focusing on in this assignment are parallelograms and triangles. Parallelograms, so these shapes, here's kind of their universal symbol of how they look. Parallelograms, opposite sides are parallel to each other, opposite angles are also congruent to each other. We've talked about that earlier this year. But the area formula for a parallelogram is just the base times the height. So to give you a little bit more clear, if I have a parallelogram right here, like this. If I said that this one was the base, it's on the bottom of this parallelogram, the height is not this. This is what we call like the slant height. This is just another side. The height of this parallelogram, we're talking about heights, we're talking about altitudes. They have to intersect at that right angle in order for you to identify that that is going to be the height. So a parallelogram, similarly to like a rectangle or a square, the area formula is the base length times the height, and that's it. And we'd answer in square units. So whatever the units that they use, it's going to be square units, because that's how we establish that we have area that's being talked about. The area for a triangle looks very similar to this one. I'm going to come up a little bit. The area of a triangle is, and you've probably seen this a couple different ways, but it's base times the height, and then all of that is divided by 2. Okay, so a little bit different. And so you might notice that same formula as the parallelogram was divided by 2, and that is absolutely correct. So an example, if I've got a triangle and I'm looking for the area of it, again, in order to have the height, I need to find an altitude. Right, so I have to go to a point, I have to have a right angle, and this would be my height. So base times the height divided by 2. The tricky ones with triangles is sometimes the height can look a little different. If I told you that this side was the base, where's the height going to be? So it can't just be this. This doesn't work. That doesn't work because I've got a point that's actually taller than that. So when we're talking about the height, I've actually got to go to this tallest point out here, and I'm going to go perpendicular and extend this line out. That represents where my base is located. And this would actually be the height over here. Kind of a different one. Let me get. this be a dotted line too. Anyway, so those can be a little bit tricky. So going back to this assignment, I'm going to do a few examples for you, and see if you can get through each of these. I'll do 2 and 5 here. Number 2, we are asked in the directions find the perimeter and area of each parallelogram or triangle, round to the nearest tenth if necessary. Okay, so my formula for a parallelogram is going to be base times height for parallelogram. So I need to identify where the base is at. Here, if I take the 10 centimeters here as the base, this would be my height, but notice that it is not given to me. This is given to me, this 8 centimeters, but I'm not just multiplying these two together because this is not the height. So how do I find out my height here? Got the bell still going off. Nobody's in class. Well, notice that they tell me that this is a 45-degree angle. This is a 90, that means this is a 45-degree angle. This is one of our special right triangles. That tells me that these two sides are going to be congruent to each other. And if this is my hypotenuse of this little triangle that shows up here, this is like one of our special right triangles, right? If this is 45 degrees and this is 8 centimeters, what are my other sides going to be? And you can, there's a couple different ways, but probably the fastest way to do it is recognize that whatever this is, the hypotenuse is that leg times the square root of 2. That was the relationship with the special right triangle, a 45, 45, 90 triangle. So I'm going to set 8 equal to x times the square root of 2, because that's going to get me what my leg is going to be, which is my height here. So if I set 8 equal to x times the square root of 2, I can divide by the square root of 2. And so if I do that, square root of 2, square root of 2, this is my answer. It's not in simplified form. They would have you, if I have 8 over the square root of 2, I would multiply that by a giant 1 here. And so I'd have 8 root 2 up top, and the root 2 times root 2 just turns into 2, and you could simplify that, and so this becomes actually 4 root 2. Some of you will do that. A lot of you will just put in your calculator what 8 divided by the square root of 2 is, and you'll come up with the decimal. So if I do 8 times the square root of 2, I get 11.31. So again, this is 8 divided by the square root of 2 is what that equals. So you can put that in as well. Oh no, I didn't do divided by. Excuse me. 8 divided by the square root of 2. There, that's going to be better. Caught that. 8 divided by the square root of 2 equals about 5.656, and well, let's round here to this hundredths place right here. So this is the value or it's equivalent to 4 root 2 this side. But since I'm trying to find the area of this parallelogram, I'm going to do 10 times 4 root 2, and that just comes out as 40 root 2 centimeters squared. So this is my area for this one. But I also have to find the perimeter. The perimeter is a little bit easier because it's a parallelogram. So that means that this side is 10 centimeters. And then this opposite sides here are also congruent. So this is 8 centimeters. So when I add up the perimeter, I'm going to go 10 plus 8 plus 10 plus 8. And that ends up being 36 centimeters. So there are both my answers that I need for number 2. And you can see work shown over here, but that one's kind of a little tricky one. This one looks like it's a little similar to this one. This is another special right triangle, and so remember with a 30, 60, 90 triangle, we've got whatever the short leg is, the hypotenuse is twice as big as the short leg, and then the long leg is a short leg times the square root of 3. So if this is my 60-degree angle, this is my 30-degree angle. Remember that relationship for number 1 to help you out with that. Okay, and then moving down to number 5, or same thing, I'm trying to find the area and then also the perimeter of this one. This is letting me know that the height here is 20 inches. This base looks like 12 inches. And because this is a right angle, I can actually find out what my hypotenuse is going to be using the Pythagorean theorem. So I can go ahead and do 12 squared plus 20 squared equals c squared. And when I do that, 12 squared plus 20 squared is 544. And then when I take the square root of 544, I get about 23. This comes out as about 23.32. And we're in inches here. Okay, so that's all I really need, the missing information that I need for my perimeter. So I'm going to add 23.32 plus 20 plus 12. And my perimeter on this one is going to be 55.3, round to the nearest tenth. And my area, I've got to do base times height divided by 2. So 12 times 20 divided by 2. And I come out with 120 square inches. Up here, this was just inches up here. So here are my two answers for number 5. So, if you do have any other questions, let me know. But look for how you're going to find out those heights and bases. Sometimes they might be a little tricky. Let me know if you have any questions. Email them to me, and should be able to get it all done.